Hello, everybody. Welcome to science class. Hope you're having a good digital learning day. Let's get to it. For your what should you be forgetting today? A little memory practice here. What I want you to do when it's time to, I'll have you pause this video and you can go into your Google Drive. Remember, we have this world tour document. If you look in your drive, it should be under copy because you made a copy, so it'll be alphabetically in your C's. B, C for me. You go find it. If you can't find it, if you type in WEDS world, it'll probably pop up there as well. I have lots of copies of it because I've copied it a bunch of times. But there's mine, my Google Drive. So you're going to open that up. And yesterday, you'll recall we learned the different agents of mechanical weathering, also called physical weathering. And they were abrasion, ice wedging, plants and animals, gravity. There was also another one that's not on here called exfoliation that occurred when a rock gets really hot and it kind of like peels off in sheets like this. Those are exfoliation right there, weathering. That's not on the list, and nothing on your world tour was caused by that. So what you'll do, I want you to do now is go through your world tour, and any of them that were caused by mechanical weathering, I want you to put the type here. So like for instance, Bryce Canyon definitely was. If you look back in your notes at those different ones, think very quickly, sorry. Well, this or not. There it is. Bryce Canyon, you can look here and kind of use your inference skills to like, how are these towers of rock formed? And you might remember they formed much the way arches do. Anytime you see strange rock formations, it's usually from wind and sand, water going on there. So wind, sand, and water is not one of them, but abrasion is. And that typically makes those. So here you can put formed by abrasion. So once you go through your world tour, take a look and see if you can tell which form of erosion caused a thing. Now, or weathering rather. Some of them won't be caused by any of these. You'll see some that looks like something else, and that's just because we haven't done them yet. Some are caused by chemical weathering, which we haven't talked about yet. Some are environments of deposition, which we have. So we're going to do that as well. If you see some and you're like, I don't totally know which of those four it is, then it's probably because it's one we haven't talked about yet. So don't worry about that if you see them, but lots of them are. You know, deltas are deposition, marshes and swamps are deposition. So a lot of these you'll be able to do, but if you do see one that looks like, I don't quite know how that got that way, don't worry about it. It's because we haven't done it yet. So pause here, go ahead, open that document and do that first. Fill in which form of weathering created each thing. That'll help you remember those forms of weathering and recall what we did yesterday. And when you have done and filled that out, come back to the video and unpause and continue. All right. I want to go back to talking about models. You're creating a model or maybe more than one model at this point in class as well. I want to ask you a question today. Here's a model of a barrier island. What strengths do you see in that model? What did the creator of this model do well? What weaknesses do you see? What did the creator of this model do poorly? If you will, please pause the video here, think through those two questions. You're ready to go, pause again. All right. So much like you just tried today I want to teach you how to analyze the strengths and the weaknesses of models that you see. We have been talking about models. We talked about them for a while ago in class before you're making them. A couple things to remember about models. Scientists and engineers develop and use models to help people understand ideas that are too big to see, too small to see, too invisible to see, too complicated to see, too slow to see. Models are all about helping you see something you can't normally see to help you understand it better. That's what models are for. And we also talked about what types of models you may see in the world. Move this. Yeah, can't move that. Good. Move that out of the way. So for instance, physical models are things you build. So somebody built this model to create that delta to show you how those are formed. They can be diagrams. Diagrams are usually something you draw. So that's how do sand dunes form diagram. They can be animated. You'll notice this delta model down here is animated, which is pretty cool. Animation, since these things happen through a process, it's nice to see them do that. And then time lapses are series of photos or series of images sped up really fast. So this is like 30 years of this barrier island forming. Super cool, super hard to do because you have to have photos of the same place over and over again. But pretty neat. Those all count as models. A lot of times we think of models only being something you build, but they're really anything that helps you see a process that you can't normally see. All right. So reminder, today I wanted to teach you how to analyze strengths and weaknesses of models. Start evaluating them like a scientist would do. The big thing to remember is that good models should do two things, not one. They should show you what the landform looks like, but they should also show you how the landform is created or how it changes. That's the key to these. Not just like, oh, that's what that looks like, but where did that come from? So let's look at one together here. This is the model you looked at previously of a barrier island. I left the advice over here so you can remember it. And let's talk about strengths and weaknesses of that model. So when I look at that, let's start with strengths. Strengths are things the model does well, that the creator of the model did well. One thing when I look at this one I love is that it really shows the landform really well. Barrier islands are tough to understand, I think. Like most people don't know what they are, and since they're so big, if you're like on one, it doesn't even look like an island because they tend to be really, really large. And this one really shows well. I like how they labeled, like, here's the ocean, here's the island, here's the bay, here's the, there's water in between the island and the mainland. Looks super cool. I like how the barrier island looks big. I like how it's like it's not, you don't see the water up here and here, so it makes it feel kind of like a bigger creation, which they tend to be. And really that is great. Like that that's about as well as I think anybody could diagram a barrier island. You can see really clearly that there's water on both sides of it. You can see really clearly that it's very close to the mainland. I'm going to put that too, close to mainland, so you don't confuse it with the other kind of islands you find in the ocean. Maintain close to mainland and all that. I think this person did just an excellent, excellent, excellent job of showing you what a barrier island is. I don't think they showed very well how a barrier island forms. Doesn't show how the barrier island formed at all, in my estimation. Doesn't show, I'll put formation. The problem with that is, like, that's great to know what a barrier island is, but if you don't know where it came from, it's easy to think like a selfie tourist and be like, oh, barrier islands are just there because they are. It doesn't show any science behind it. It doesn't show where they come from. It doesn't show why it's so logical that you would have an environment of deposition near the mainland at all. So I think that's a key. Good models show how the landform, where it comes from, and this doesn't really do that. So I would say that's a weakness of that model. That's often a weakness you're going to see, is a lot of models just don't do that well. Let me do one more before we do it together and do some writing. This is an animation of how a swamp forms. Let me give you a moment to just watch it a few times. It repeats itself. Cool. So neat model. As I look at this, strengths usually jump right to mind to me first. Like when I look at things, I'm like, oh yeah, like first of all, even doing an animation at all really changes this because it kind of shows the river flooding, which is a big part of how swamps form. And so I think, like, right off the bat, I can see the water level rising so much that it ends up going over the land. And you often, when you see swamps, you think of it, it almost looks like trees growing out of water. Well, I wonder why they're doing that. And it's because of the flood. And I think that's really good. My tree. I think that's a really good part of this model, is you can see the river rise up, flood, and take over that area there. So I think that's a big strength of it. That's my favorite thing that jumps out to me as I see it. A couple of things I don't see One is I don't see deposition. In any good landform model, I'm going to want to see the weathering and erosion, or I'm going to want to see the deposition that creates it. When the river floods, we get deposition over here too. The river's going to, much like at a delta, the river's going to drop off that sediment there. And that's part of what makes it such a fertile place, why there's so much plant life there. And you can't see that happening here. You can see the flood happening. You can see that there's sediment down there, but you can't really see how any sediment gets into the swamp that makes it the swamp. Because remember, in landforms, we look at the land and not the water. The other thing I don't love about this is I can't even really see the landform. Doesn't really show me what a swamp looks like, or at least not what I'm used to seeing. So it does a great job, I think, of showing the main cause of a swamp, but there's a detail in that process that I don't see. And I don't really have a sense of what a swamp looks like. I can see the parts that are like that here. There's the river, there's a marsh, and there's the forest, all of which are underwater when the river floods. I think that's cool, but I don't see some of the things I would love to see. I can't really, especially, I kind of see how it forms, but I also kind of don't see how it forms. All right, let's do one together. If you'll open your science notebook, here's the example I want to do. We'll put this in your notebook. You do it. This is a diagram model of a beach formation. Why don't you go ahead and pause the video here and take a look and kind of get a handle on what you've got. Then we'll talk about some strengths and weaknesses. All right, so looking over that model carefully, you'll notice this doesn't totally show us how a beach forms. What it really does is show us how does a beach change during a storm. Many of you asked about that. Don't the waves also erode beaches? And they do, especially during storms. And then how the beach repairs itself after a storm, which I think is pretty cool too. So cool idea for a model. I'm going to start there. Right off the bat, a strength is it shows how the beach changes. I love that. It also shows erosion and deposition. I think a lot of people wonder that about beaches is, don't they involve erosion? When I go to the beach, I see some of the sand get swept back into the water, and you certainly do. And this kind of shows you that that does happen. All this sand at part of the day goes here, and certain events goes here, but then it also is replaced by deposition. It comes right back up when the waves come after. So I think that's really cool that it shows both of those processes, and teaches us something new about a beach too. I'm going to add that as a strength as well. Teaches new idea about a beach. Really helps you understand beaches better than you may have before. I'm impressed. I'm going to get picky here. I actually think this is a pretty good diagram, but all diagrams have weaknesses too. You can't do everything in one model. There's things you can accomplish in a model and things you can't. I guess if I was like being really, really picky, I can't see. Well, no, I shouldn't say that. You can really see like this sand goes here. I was going to say you can't see the erosion and deposition happening totally. I would like to see the word deposition in this bottom part. I don't think they do that. That's the scientific word for how they form. They talk about things like moving, that's erosion. They talk about building up, which kind of is talking about deposition, but doesn't really show that. And it also doesn't give doesn't show the beach totally clearly, the formation totally clearly. It's not terrible, but from this side profile, it can be hard to tell, like, that's like a beach that you would be sitting or standing on rather than like some kind of cliff or something like that. So I think that's picky. These are picky weaknesses. I really think this is a very good model. I think it, like I said, does a great job of showing you how part of the beach erodes during a storm, and then that part ends up, you can see where it used to be, and it ends up back there. Pretty good. Y'all, this is a distinguished skill, being able to analyze strengths and weaknesses of people's models.